this, like the inbuilt board which we have designed. So this is the keypad I'm going to use. It has the pull-up resistor here, but I'm not going to use that pull-up resistor. So you could also use a similar kind of keypad. Okay, you can also use this similar kind of keypad which is available in the market. So both are quite same. Like this does not have a pull-up resistor, so you could use the pull-up resistors which is inside the microcontroller. Okay, so in this board I have pull-up resistors. You can also use pull-down. Okay, so it will be connected this R1, R2, R3, R4, and C1, C2, C3, C4. Okay, so these are the switches. Totally there are 16 switches. So when you press the switch, like the C1 will be connected to R1. Okay, so R1, R2, R3, R4 will be connected to the GPIO, general purpose input and output pin, which is configured as outputs. Okay, whereas C1, C2, C3, C4 will be connected to the GPIO, which will be configured as inputs. Okay, so this C1, C2, C3, C4 should also have pull-up or you should connect it to a pull-up resistor. Okay, now usually this resistor will be of 22K, and it will be like 5 volt or 3.3 volt, so that whenever you press the switch, okay. So the reason we connect pull-up is, if you don't connect pull-up, and this will be open. So okay, so this will be open, and if you try to read this, C1, like, so you will have a voltage fluctuation from 0 to 5 volt. Okay, so in order to put on some stable state, you should connect it to a pull-up so that it will be 3.3 volt. Okay, so when you press the key, and this is the output mode, like R1 will be connected to the output, and when you press the key and if you make it a 0, like you will get low. Okay, so C1, when you read that, so it will be grounded, so that you will get, when you try to read C1, it will be low. Okay, so when it is not pressed, it will be high. Okay, so we are going to like, in order to press the key direction, okay, like you have to first select this R1, R2, R3, R4. Okay, and then we will be using the keys, we'll be reading the C1, C2, C3, C4, and we'll be checking whether it is 0 or 1. Based on 0 or 1, like, we'll be checking whether the key is directed or not. Okay, so so first, for pressing the C1, for testing 1 2 3 4 1 2 3 4 or 1 2 3 A, like you can enable this R1 and try to find out this, what key has been pressed. Okay, for detecting 4, 5, 6, you have to enable R2, R3, and R4. Okay, similarly like that. Let's go for the program. So you need to introduce a delay for key debouncing, because else, like, it will direct multiple directions. So you need to give a delay before a printf statement. Okay, I'll show you on the code. So it's a very simple logic. You have to give pull-up for C1, C2, C3, C4 pull-ups in order to give a stable state. Okay, you can use pull-up or pull-down. And here C1, C2, C3, 4 will be configured. The row will be on the output mode, and C1, C2, C3, 4 will be connected to the input GPIO, and this will be the output GPIO. Okay, so you can enable R1, R2, R3, 4 to check whether C1, C2, C3, 4 which key has been pressed. Let's go for the program. First, I will open a folder. Okay, so I just copy this part and I open STM32Cube IDE. Okay, it should be target. I have given as host. So I'm going to use port C in our board. Like I'm going to use port C. So for port C, C0, C1, C2, and C3. Okay. So these 4 pins, I'll be using it as output modes. Okay. C0 to C3 will be configured as an output mode. And I'll be connecting the rows of the R1, R2, R3, R4. Whereas for C0, like C4, C5, C6, C4, PC4, PC5, PC6, and PC7. Okay, will be configured as input modes. Okay, will be configured as input mode. And let us check. Okay. So you have to give 0 in order to select. In order to select this R1, you have to give 0 to R1. And you read this C1, C2, C3, 4 to detect which pin has been pressed. Okay, in order to select R2, give 0 to the R2 and check which pin has been selected, which pin has been pressed. Okay, you need so you need to give a delay for debouncing. Okay, let's go for the program. Start a new STM32 project. Okay, click board selector. Choose the board, like we are using Nucleo F411RE. Choose this board, click next. So I'll just type example1, okay, and choose the project as empty. Click finish. Okay. Click finish. Okay, source file. Let me check for this. Right click and build the project. Okay. So I just in order to check the visualization, like I will I'll download this empty program to see the output registers. Okay, to see the to memory map. Instead of seeing the data sheet, I'm going to use the memory window to check the address of port C and the mode registers and the RCC registers. Okay, so which we have done on the previous experiments. So first I will increase the size of the editor. I go for window, choose preferences, click general, okay, click appearance, click colors and fonts, C++, editor, click editor, click text fonts, choose 12, 20, okay, apply and close. Okay, so first thing, I'm going to use printf, so I will also use std io.h. Okay, io.h. So since so at first I'll go for window. I will choose for the show view. Let me choose the SFRs, special function registers. Okay, so first I'll check the value for the RCC. AHB1 ENR is 040023840. Okay, so let us first, you have to enable the clock. Okay, enable the clock because port C is connected to AHB1 ENR. Okay, so you have to enable this clock. So first we need to declare uint 32_t pointer variable of port. This is C, so port C, let me port C AHB1 ENR. Okay, So you have to, sorry, you have to typecast this one, typecast. Okay, 0x 400 AHP 400, sorry, 4002 3830. Okay, it is 3830. You could see the address here, 0x4002. Okay, 3830. And let us declare the, okay, so I'm going to use the port C mode, or the next is mode or register. Okay, and we need the output data register. We need the input also. So for input, you need input data register. Okay, to read the inputs, you could check out in GPIO-C. On the registers, you could go for GPIO-C. Here it will be the mode or register is 04002 0800. Okay, 04002 0800. Okay, and ODR is 0814. This is ODR is 0814. Okay, IDR here is 0810. IDR is 0810. It is here. IDR is 0810. Okay, and we need to pull up and pull down. Like we are going to use internal pull up and pull down. Okay, PUPDR. I'll show you on the data sheet. We have one more register called, we have internal pull-ups. Okay, if you are going to use internal pull-ups, then I need to configure this 080C. Okay, 080C. Okay, so let's configure. We have configured this address. Now let's check. Okay. Okay, so now we have configured this one. So the first thing is to you have to enable the peripheral clock. Okay, peripheral clock for port GPIO-C. Okay, GPIO-C. You have to enable the peripheral clock for GPIO-C on the RCC register. Okay, I'll show that on the RCC register. Okay, we just go for general purpose IO RCC registers. Okay, you click RCC register. So you have to RCC AHB1ENR. You have to go for AHB1ENR. Peripheral clock enabled registers. Okay, clock interrupt. It is here is the value. Peripheral clock enabled register. We have to enable GPIO-C EN here. Okay, 8421 421. Okay, so 4. So we have to okay, so we have to enable this value 4. Okay, so you could also give this as you can OR it by one left shift of 2. Okay, so we have enabled this one, or you could also use both are same, 0x04. Okay, you have to set the bit. So both this one and this one are both are same. Okay, I'll go the first one. So now you have to configure, the next thing is you have to configure the GPIO, like PC02, like in port GPIO C0. Okay, I'm going to use PCO, like port C, this is the 0th pin, to PC3. Okay, PC3 as output, and PC4 to PC7. Okay, PC4 to PC7 as input, so in this, you have to go for the mode register. Okay, GPIO purpose, like general purpose input output, click GPIO registers, port mode register. Okay, this is the mode register. So we have to configure. Let me show this here. Like you have to configure 01 for output mode. Okay, so it should be, this value should be 0. Okay, and here it is 1. Sorry, here it is 1. Okay, 0, and here it is 1. Sorry, 1. Okay, this is for 0, 1, 2, 3, 4. Okay, PC0, PC1, PC2, PC3, all are outputs. Okay, so you have to configure here 1. Okay, and this is 0, and this is 1. Okay, whereas for the rest you have to configure as the input is 0, 0. Okay, so from here you can configure this is 0, this is 0, this is 0. So 0, 0, 0, 0. Okay, so this is 0, 1, 0, 1 is 5. Okay, this is also 5. So you have to, before that you need to clear all this to 0. So in order to clear all this to 0, you have to begin with this is FF. Okay, so let me show in the program. So first, okay, so first you copy this mode register, configure as input and output. Okay, so before that, first you have to clear the bit 0xFF000. This is for clearing. Okay, for mode or register. Copy this one, and to set this you need to use OR operation. Okay, so 0055. Okay, so we have set the mode register now. Now the output data register. Okay, output data register. Before that, we need to configure this pull up and pull down. So we need pull up only for the pull up. Let me show in the datasheet. We need pull up only for the columns. Okay, so GPIO, this is the pull up and pull down register. Okay, so we need pull up only for the columns are here. Okay, the row is 0, 1, 0, 1, 2, 3 is row. For that there is no pull up is needed. Okay, only for this 7, 6, 5, 4 we need pull up. So pull up is 0, 1. Okay, pull up is 0, 1. So we need to set okay. So if you check, like you need to set okay 0, 1. 0, 1 is pull up. Okay, for this you need to set 0, 1. Sorry, it should be 1 here. it should be 1. Okay. Okay, so 0 and this is 1. Okay, this is 0 and this is 1 and this is 0 and this is 1. Okay, to set pull up for this, no pull up 0 0 0. So this is 5 5 0 0 0. Okay, so I just copy this pull up. Okay, first you need to clear that one. So for clearing I'll be using the same thing. Okay, and for okay, 0x000 5 5 and 0 0. Okay, this is for pull up. To have internal pull ups, we are setting pull ups inside the microcontroller. Okay, so no need to have an external pull up. So let's make a while loop. So while of 1. Okay, so first, here is the concept. Okay, the first what we are going to do is we are going to set R1 as 0. R1 we are going to give 0. So R2, R3, R4 is all 1. Okay, or all 1. So R1 we are going to give 0. We are going to give R1 0. And we are going to like R1, R2, R3, R4. So R1 we are going to give 0 and the rest of the thing is 1. Okay, so we are going to read C1, C2, C3, C4 and check whether we are getting high or low. Okay, so usually it will be high. When you press the switch, it will be low. So let us check. First you need to give R1. R1 is nothing but output data register. So I just copy this. Okay, first you need to okay, so set, you need to R the value like 0x0f. Okay, which is all 1, which all the 4-bit will be 1. Now you have to do an AND operation. Okay, so negation of 1 shift 0. Okay, so we are setting only the least bit. Okay, and we try to read this. Let us try to read this input data register ports. Let's read this input data register. You AND with 1 4. Okay, so you need to use the brackets. So I just close this one. Okay, so this brace is closing at this brace. Okay, this brace is closing at here. Okay, now here it's closing at here. So we are checking whether it is 1 or 0. Okay, if not equal to, it means 0. So here like we are giving like printf So printf 1 is pressed. Okay, 1 is pressed /n. Since we are using printf, we have to use the ITM, like we have to add some snippets on the syscall. After completing the program, we will add. Okay, so this is to find out 4, 5, 6, and 7. Okay, you have to because like we are giving 4, 5, 6, and 7 because we have this is 0, this is 0, 1, 2, 3. Okay, so 4, 5, 6, 7. Okay, so we are connecting to PC4. Okay, so we are shifting this 1 to 4 bit. Okay, and we are doing a bit n with this input data register to check whether it is 1 or 0. Okay, so if it is 0, it will print off 1 is pressed. Okay, print off 1 is pressed. So we need to introduce a delay here for key debounce to avoid key debouncing. So first we'll complete the program. So I'll just add a delay program, delay of, okay. So I have to declare the delay on the top. Okay, so the same code in the previous experiment, void delay of void. Okay, so for volatile uint 32 underscore t, so I equals 0, I less than 30,000. Okay, I plus plus. Okay, so we have made the delay. So this has to be checked. You have to check this condition for all the pins. Okay, for all the pins. So I'll terminate this program. Let me move some indentation. Let me give some indentation. Let me check for edit. Okay. So printf 2 is pressed. So I'll copy this. This is 5. Okay, so copy this. Okay, this is 6 and this is 7. Okay, so 3 is pressed and here 4 is pressed. Okay, so this is for the first row. So for the second row you have to copy and paste. Okay, so this is the end of while loop. Okay, so I just copy this code. So I'll just give this is make R1 low. Okay, so I just copy from here to here, copy this and paste it again. Okay, so this is make R2 low. So now to make R2 low, like it should be the next position. Okay, the rest of the code is same. 4 I just give here as 5. Okay, and 6 7, 8. So I just copy okay. So this is make R3 low. So R3 is 2 here. Okay, we have to give 2. The rest of the code is same. 8. This is 9. Okay, I'll just give this is 10th key. This is 11. Okay, you can also have A, B, C, D, 12. Okay. And I'm just making this as R4. Okay, so this is 3. Here it is 2, it's 3. Okay, so the rest is same. This is 13 and this is 14, 15. Okay, and it's 16. 16 is pressed. Okay, so we have completed the code. Let me check, right click, build the project. So we have 2 errors. It's 32. Okay, right click, build the project. Okay, so debug as okay. Switch for debug view. So before that, we have forgot to add the printf code. You just go for syscalls.c. So we need to add some code here to display on serial wire viewer. Okay, so I have the code here on syscalls.c. Okay, you have to copy this code and you have to paste it on. You have to paste it on this syscalls.c. Okay, copy this ITM sendCat and you need to modify this code at write function. Okay, you comment this line. Okay, and you just copy and paste. So right click, build the project. Okay, so right click, debug as STM32 C++ application. Let me show that on the first. I'll show that on the registers. So first I'll put a breakpoint here. I'll switch to the debug mode. So first let us check whether we have enabled all the registers. So I put a breakpoint at line number 29. Okay, 29. And let's go for the step by step. Okay, so we are executing step by step. So this will enable the GPIOC. Okay, this will enable the GPIOC register. So if you check on the STM32, like you go for the RCC register, like you click for AHB1 ENR and you check for GPIOC EN has been enabled now. Okay, so this is right. Okay, we have enabled the GPIOC because we are connecting to port C of the controller. So we have enabled this port C. It's right. Okay, the next is mode register. Okay, so the next is mode register. On mode register, like we have chosen GPIOC here. Okay, this is the mode register. We have to set this inputs and outputs. Okay, so this will be the output and mode 0 1. Okay, 0 1 2 3, this will be the output. So output, it will be set, the rest of the inputs. Okay, so if I go step by step execution, okay, so output has been configured. Okay, output and input is also configured. Okay, so we have set the modes as output. So mode register has been set. Now the pull up and pull down register, okay, PUPDR, to set internal pull-ups. So this is PUPDR. So if you go step by step execution, like that also has been set. Okay, so we have given pull-up for the columns. Column is connected to 4, 5, 6, 7. Okay, we are connected to C4, C5, C6, C7, port C4, port C5, port 6. We have connected the pull-up, so that has been configured correctly. Okay, so that is also right. Okay, so we have to make in the output data register, we have to make R1 as low here. Let's go for step by step execution. Okay, so we have enabled all this 4 as 1 now, and the rest of the only we have to enable R1, like here it is R0, it is 0, the rest of the thing should be 1. Okay, so if you check here, we have set only this R0. So if you see in the block diagram, okay, so we have to like R1, this is here it is R0, R1, R2, R3. So in our register, like it is R0, R1, R2, R3. Okay, so we have to enable only 0 for this, the rest of this thing should be 1, 1, 1. Okay, and we have to read the inputs. So if you check here 0, 1, 1, 1, and we are reading the inputs. So here, like, and if it is pressed, like we'll get a 0, delay printf is 1 is pressed. Okay, else 2 is pressed. Okay, so if it is not pressed, then it will go out of the next one. Okay, I have not pressed the switch. So if I press the switch, okay, if I press the switch, let me check it's R2. Let me press the switch and I try to execute. Okay, it goes inside this code and check printf. Okay, so we have forgot to enable the console. Let me check Windows, go for appearance, show view, software wide serial wide view, item data console. Okay, you click this one, enable this port 0, click OK, and click this trace. Okay, start trace. Okay, so let me check for the next one, and I try to execute port 3 now. Okay, so it's, you could see the display on the printf, 3 is pressed. Okay, so 3 is pressed. So let me take the breakpoints and I just run this code. Okay, I just remove the breakpoints. Okay, and I go for resume button. Okay, now I press first now. Okay, so this is due to the delay, like 3 is pressed, 4 is pressed. Okay, 5, this is 6, okay, 7, 8, okay, 9, okay, 10, 11, 12. So we are printing twice. It may be due to the debouncing. Okay, let me increase to 4. It should be 200 milliseconds. Okay, you have to clock in the next experiment. Let us clock how to calculate the perfect delay. Now I have increased this one, build the project, and let me check again. Okay, debug as STM32 Cortex application. Let me check once. You can also use this one. Okay, both are same. You can also use this one. So switch and press the resume button. Okay, so go for this data console. I press 1. Okay, so now there is no 2 times. Okay, 6, 7, 8, 9, 10. Okay, 11, this is 12, 13, 14, okay, 15, and 16. Okay, 16 is pressed. Still some delay problem is there. Okay, so anyhow, you could reproduce this code and you could try it from your end. It will work fine. So we have come to the end with this. I close the session. So thank you